In this video, I'm going to talk to you about residuals. And residuals are what we're going to use to help us measure or judge the appropriateness of a linear model when we do least squares regression. And when we talk about the residual, a residual basically says this: if we're making these predictions on this line right here, the values are either going to fall one of three ways. They're going to fall on the line, which means that our predicted value measured up to our actual or observed value, or they're going to fall above the line, or they'll fall below the line. And remember, this line itself right here is just your least squares regression line, and that is a mean. And so any value that falls on the line itself, any value on this line itself is going to be a predicted value. They say predicted value. Remember, we call our predicted values, we call those y hats. So these are y hats. And then you have some values that are going to fall above the mean, such as this one. And then you're going to have values that are going to fall below the mean, such as this one. And remember, if this occurs, all it's saying that if it's above the mean, that means that when this line was being used to predict, the line came under. And so if a value falls above the mean, or if you have a positive residual, and again, let's talk about a residual real quick. A residual itself, a residual is just it's the vertical deviation from the least squares regression line. So this is the vertical deviation. Remember, deviation is how far away from the mean you are. So how far away at this point from the mean? We're looking at that vertical deviation from the least squares regression line. Right? And so to calculate that, then, if we're calculating just the residual itself, the residual is equal to the observed value, so wherever the value is falling at, minus the predicted value, or the value that our line was at when we use it to predict. Another way to write this is our observed, we call that y, minus the predicted is called y hat. And so now, if it's a positive residual, which means that it's sitting above the actual value, positive residuals means that the value was, the least squares regression line itself was an underestimate. So if we get a positive residual, that means that the least squares regression line underestimated, because that means it came underneath this value like this. Here's a positive residual. We're underneath it. We're underestimating there. And if we get a negative residual, that means that the least squares regression line was overestimating at a particular point. It was overestimating. And again, look here, we're negative, so we're coming beneath that now. So we can assess the model fit, because what that means now is that if we see a lot of values that are, if we see a lot of positive residuals, which means lines that are above the actual thing, the actual least squares regression line, our line is continually underestimating. We need to adjust that. Likewise, if we see a lot of negative residuals, our line is overestimating. We need to adjust that. And so what we can do is create this plot right here in what we call residual analysis. And what it does is it takes these values and it centers them at a value of 0. And so we start looking at the values that are above and below. And if the line is a good fit, a linear model is a good fit, we expect to have some values that are above the line, some values that are below the line, or even some values that are on the line, depending on where you're at. We don't want to see it where we see patterns, though. And if you look here at this pattern, we have a definite amount of values below, definite amount above. That means there's a better fit out there. Likewise, this is a very quadratic pattern. And if you look at something long enough, you can pick a pattern out. So when we talk about patterns, what we want to see is, we want to see random scatter. If it's random like this, if this is random, that means a linear model is a good fit. It means linear is a good fit if it's random. If you start to see patterns such as here, that means that some non-linear model is a better fit. These are non-linear. And so what we're going to do now is we create this plot, this residual plot, and we look at that to assess the model fit. And we're going to talk more about that, looking at the model fit. And then the other thing we're going to look at this value we call the coefficient of determination. And it's going to help us determine which model is the best model when we create these things. So let's look at this example here. And this says that Noah tested several men of different ages to see how many push-ups they could complete in a row without resting. An approximate least squares regression line was used to predict the number of push-ups from a given age of men. So you have your explanatory variable, which is age, and your response, which is the number of push-ups. I want to interpret the residual for the man indicated in the scatter plot above. So notice their residual is sitting here. So they're predicted to be at this value right here. So they're predicted to be at 28. But their actual number is, so y hat equals 28, but the actual number, y, is equal to 18. So your residual, remember, your residual is equal to y minus y hat. So we have 18 minus 28. And it's equal to a residual of a negative 10. So in this case, because the residual is negative 10, he was predicted to do 28 push-ups. He was predicted to do 28, but he could only do 10. But he can only do 18. So that means he fell short of his predicted value by 10 push-ups. So in this particular problem, then that means that this man completed 10 fewer push-ups than his predicted, and based on his predicted age.